Okay, here we address the question as to which is the hardest carbon allotrope. Now recall, an allotrope is a form of an element, and we're talking about the elemental forms of carbon. And so one elemental form of carbon are what they call the Buckminster Fullerenes, or just Fullerenes, or sometimes they're referred to as buckyballs because they're kind of spherical shaped. Here's a model of a 60 carbon fullerene called C60. If you look at this in this model, all of these carbon atoms at the intersections of these bonds have a sort of a trigonal planar geometry. They're all sp2 hybridized. They're all covalently bonded within the surface of the ball, but between two fullerene molecules, there's very weak interactions, more like London forces. And so, as a net result, is that this a sample of fullerenes would not be very hard at all. These spheres would be able to slide past each other pretty readily because there's very weak interactions. In a similar fashion, we can talk about graphite. That's another form of carbon, another carbon allotrope. And as I show you the structure here, you can see that it has sort of a layered structure. If we look at it from the top here, we can see that each of these carbons, again at the intersection of these bonds, are in trigonal planar sp2 hybridized arrangements, and we have these six-membered rings that are arranged in sheets. Now, within the sheets there's covalent bonding and there's fairly strong attractions. Between these sheets there's very weak interactions, and these sheets can actually slide past each other, which makes graphite really soft, which makes it very useful for being used inside of a pencil. Okay, so that is not a very rigid carbon allotrope. Now the hardest carbon allotrope is a diamond. Okay, and here's a representation of a diamond. What we have here is that each of these carbon atoms, you look in the interior carbon atoms, each of these carbon atoms is bonded to 4 other carbon atoms, not just 3, and there's covalent bonding in 3 dimensions. This is sp3 hybridization. Now these carbon-carbon bonds are short and strong, and what we have is this network 3-dimensional bonding, which results in a very hard material in all 3 directions. So diamond is one of the hardest substances known, and it's definitely the hardest carbon allotrope.